Hello, and welcome to my session on making with microbits. I'm really excited to be presenting as part of the International STEAM Summit, and I wanted to especially thank Wonder Workshop for putting on this wonderful opportunity for everyone to learn about integrating STEAM into their classroom. First of all, I wanted to talk about a little bit about myself. So, my name is Andrew McDonald. I'm a technology educator at the University of Ottawa Engineering Outreach Team. I'm a former classroom teacher, and I'm excited to be able to share with teachers and students various technologies and bringing those into the classroom. I'm a CoSpaces ambassador and training partner, as well as a Makey Makey ambassador, a Makey Makey certified educator, as well as a training partner. I'm also a Raspberry Pi certified educator. So, what are the objectives for our session tonight? Well, first of all, we're going to talk about what is the microbit. We're going to dive into a couple processes on how you can use the microbit in the classroom. And then I'm going to talk about a few of the projects that I've created by myself or with my son to think about how we can build with the microbit. So, what is the microbit? So the microbit is a small pocket-sized computer that's able to transform digital skills into some physical skills. So we've got here an image of the microbit. So we can see on the front we've got a 5x5 LEDs. Those are red LEDs. We've got two buttons. We've got a USB controller that allows us to connect to our computer. We've also got a compass, so we can measure magnetic field, both terrestrial and from external magnets. We've got an accelerometer, so we can see how fast it's going, how fast it's moving, as well as the orientation of the microbit. We've got radio and Bluetooth capabilities, so that allows us to connect or communicate between two microbits, as well as microbit and other Bluetooth devices. And down at the bottom here, we have an edge connector to allow us to connect accessories. And so this allows us to get some really interesting opportunities, and I'm going to showcase some of those later today. So some of the technical requirements that you might have with your microbits. So first off, how do you create with the microbit? So there is various online and offline opportunities to code with the microbit. And here we have an example of make code, which is the sort of standard platform to use to code the microbit. And as well, you can also code on the tablet and on a smartphone using the microbit app. And so it allows you to connect with it. And so there are a few opportunities for students to get creative. And then how to explore with a microbit? Well, I've just got a few examples here, and so you can either disconnect it, or you can disconnect it from the computer and connect a battery pack to it. And once you've connected a battery pack, that really opens up the world of opportunities with using the microbit. And so you can see here, we can create robotic projects, so connecting it to or having it travel throughout a maze, or we can connect it to speakers and create sounds, or we can have other little projects with using communication. So I'll showcase some of these later on. But first I want to talk about some of the processes that you might want to think about when you're bringing microbits into the classroom. And so one of those is the design thinking process. And so the design thinking process has sort of got these 5 steps to allow us to go through and think about particular problems and how we would be able to solve those problems. And so the first step is to empathize. So thinking about how or reaching out to people and seeing what problems they have and how can we think about solving those. And so then through that how we're thinking about solving those, that's where your define comes in. So you're trying to define the particular problem, the challenges that are going to come up with that particular problem, and then try to ideate. And so thinking about and using this yes and mentality of coming up with a whole bunch of ideas and characteristics that could be linked in this particular project. And then once you have that idea or something flushed out, then you can start to build up a prototype or create and code a prototype. And then starting to think about, okay, let's test this out. Does this fulfill what we're looking at? Does it work? Yes or no? And then start to iterate on that. The same or similar process is called the engineering design process. And so this process has got a couple more steps, but they're very similar. And so we've got the ask, and so again, we're thinking about, okay, what's the problem? What can we do? What are the constraints that we have to do with this problem? Then we can start to research that particular problem. So what solutions exist currently out there with a microbit or without a microbit? And then we can start to imagine what sort of solutions that we can come up with. And that's where that sort of brainstorm, that brain dumping can come into play. What do we know? What don't we know? And how can we get going with this? And then once you start to get once you get all those ideas, or those ideas might be free flowing, start to come up with a plan. So bringing out some of those really good ideas, building on top of those, and coming up with a prototype. And so that's creating a prototype. Once you've got your sort of MVP or minimum viable product for that particular prototype, then you can go ahead and test that. Test it against the constraints. How does it work? Does it work? Does it fulfill what we're looking for? And then we can start to improve. And so you can start to iterate over those last 3 steps about testing it, improving it, testing and improving it, and working on your prototype. And so with that, I'm going to go ahead and we're going to jump over to my other camera and we're going to explore some of the projects that I've created and thinking about what was the process that went behind some of these projects and also how we might be able to bring those, or how you might be able to bring those into the classroom. So just give me 1 second and I'll see you in a few seconds. All right, so now we've switched over to our other camera, so we're ready to demonstrate some of our projects. So I'd like to start off with what I think is a nice way of using those the connectors at the bottom, so that those edge connectors, and so we can go ahead and connect an LED. And so in this case, we've got an LED that's right into our nose of our reindeer. And so again, just connected to pin 0 and ground for our LED. And now we can use this in circuit, so electricity in middle school. And so here the microbit is acting both as the power and as the switch. And so if we go ahead and press button A, we can see it light up, and then button B, we also see it light up. And so you can see, just like with a little bit of coding, we can explore with that case. Now, this is starting to get a little bit crafty in there, so some old toilet paper rolls and a little bit of crafts, you can start to explore with that. Another opportunity with this is also to bring something like these. You might have these in the classroom already, or those might be kicking around. But again, taking a little LED here and putting it in a circuit, and then you can connect your alligator clips to the ground and pin 0 or the signal, and again you can see the LED lighting up in that case. Then, if you wanted to go a little bit further with that, you can start to think about something like this. So this is the Kitronic stop bit, and it is connected with all 3 of these LEDs are connected along the bottom here, and allows you to do some coding with that. And so if I just do a little demonstration here, so on button A, we can see none of them light up. So actually, oh, there we are. So this is actually, button A is a randomizing of it, so it might be a failure, or as you can see, they're nicely lit up. So that's good. It looks like my code is working. And then again, on button B, has another little series, and we'll see if any of them light up again. And so here we have a nice little form factor to be able to use this with, versus something a little more do-it-yourself, something like this, or with our reindeer. And so those opportunities are there, but it's a nice getting started with exploring the edge connector, or those pins at the bottom there. All right. So just bring these off to the side, and then I'll bring in this project. And so this project is using the radio functionality as well as the math component of the microbit. So I take my main microbit here and I give it a shake, and so what that does is it sends a signal to these 3 microbits that they're ready to go and we're ready for our math problem. And so we have our 2 plus 3. So I'm going to go ahead on this main one, so my primary microbit, and then it communicates with our secondary microbits here. And so we've got, so 2 plus 3, yep, quick math does have 5. So using A and B, I can sort of move back and forth along the number line, and I use A and B together, and that will send a signal to the middle one saying, okay, I'm checking it. And so the middle one has said, yep, you're good, and this one was doing a checking, and it told me that it was 5, ready to go. So if I shake it again, we now have 2 plus 6. And so I see 5, so I will just move up to 8. So I can go ahead, press A and B together, and then you can see that we have a check mark. So again, we're using this. You can challenge your students to make something like this, either with a single microbit or something like this, a little more intensive or coding intensive, where you have to ensure that this one here, I can explain a little bit more. So this particular one is sending a random number to this. It's sending a random symbol, so it's saying if you're going to be an addition question or a subtraction question, and then a random number to this one. And it keeps track of those things, so it knows what the answer is. And so it can go ahead and check when you've compared it to when you dialed it on this one. Okay? So I'm going to have to pause here for a second while I reprogram some of my microbits, and we'll be back in just a second. All right, so this next project is getting into the sound features on the, or the sound that we can use on the microbit. And so the microbit has the ability to send out signals, and you can hear that on a speaker. And so here I have sort of the basic type of speaker, again, on a nice little piece of wood with some couple screws, so you can use some alligator clips to clip them in there. And so that's sort of a nice getting started for students. And then this particular project here was something where I was walking home from work one evening, and I saw someone was throwing out a fax machine. And so you have to think, who still has a fax machine in 2020? But then I thought, well, let's think about what we can do with maybe this headset. So I grabbed the headset and I brought it home. And so I was sitting on my shelf for a little bit, and I thought, oh, fax machines have speakers inside of them. It's got a little speaker up here. And so how can we use this speaker with the microbit? And so what I did is I went ahead and I took the back off of the headset, and I looked at, there's 4 little cables. So there's 2 cables that are in the speaker in here, and 2 cables that are in the microphone here. They go down this wire and they be connected to the main machine. And so what I did was I cut off the main cable here, and I did a little bit of investigating, essentially trial and error, with a microbit that I've connected, and I just have it send a check mark when it sends a signal, and then you can be able to hear a little bit of a signal coming out of this headset. Now, not a huge, audience can listen to this, but this is where you can start to think about, how can we use this? And what I was thinking about is this could be interesting as like an escape room type of thing, or a breakout EDU opportunity where you have one microbit is communicating with another microbit, and it sends a signal, and then there's some sound that comes out of this one. So you have to sort of work together to be able to listen, and then maybe it's a series, it could be a Morse code or something like that. So again, a fun opportunity to bring something like this, an old technology, back into use in the classroom. All right, so this next project that I wanted to show you is something that I did relatively recently. So this is, I stole the Lazy Susan from upstairs. Just don't tell my wife. Hopefully she won't watch this this session. But we have here a microbit that I've gone ahead and I've taped onto the Lazy Susan. And then what I have here is it's sending the acceleration data from both the X, the Y, and the Z axis to this microbit. This microbit I can connect ahead with the with my computer, and then I can start to measure the incoming data from this particular microbit. And then we can start to look at this. So here I'm using it in the Lazy Susan. We can also use this in other types of applications. So if we were to put a protective case around the microbit and think about tossing it or launching it or those types of things to see how the acceleration would change. So great opportunities in the science or in the physics classroom. Again, I'm going to have to do a little bit of a pause. Oh, no. My last project before I pause is this one. So here we have a clinometer. So for those that know, a clinometer is used to measure the angle of something. And so here we've got a little target on there. And so if I hold this at a certain angle, then we can use this to measure at what angle from the horizontal it is. So again, it's using the accelerometer. But instead of looking at the acceleration, it's looking at the roll and the pitch of the microbit. And in this case, it's actually looking at the roll. And so the roll is this particular way, whereas the pitch is looking at it in this particular way. And so we are more interested in the roll of the microbit. And so if we go ahead and connect here, we can use button A to show how many steps we've taken. Or if we have a microbit attached to a Trendle wheel, then we can use this in conjunction. So again, we can use this to count off. And then using B, we can now measure the angle of, to see the top of that particular object that we're interested in knowing the height of. And so those two calculations together, and a little bit of our trig functions, we're able to then calculate the height of a particular object. And so again, bringing this into the science or the math classroom as a great opportunity. So I'm just going to have to pause again just to reprogram some of my microbits, and I'll be back in just a second. All right, so we're back, and now we can start to get into some of our bigger projects or bigger opportunities. So I started off sort of smaller, and now I'm getting into our robotic or our bigger accessory boards. And so this one is called the Kate. It's spelled K8, and made by a great company called Inksmith, based in Canada. So this Kate has got a nice board here. It's also got ultrasonic sensors here in the front, and if we flip it over, we can see it's got 3 light sensors or line following sensors. And so we can use this with in the classroom with a particular mat or with black tape on the ground to have this robot travel through and do a series of challenges. So again, thinking about your students have explored with Dash and Dot programming with them. Now you can build up with some other robotic opportunities with the Kate here. And so you can also add in servos here as well, and so you can start to use it to collect things if you wanted to. Now I've taken the Kate as well to create another type of project. And so here we have an example of a model plane. It's almost a little bit too big to show here. But as you can sort of see, we've got the two wings, we've got our sort of our cockpit here, and the body of our plane. And so if I just turn this around, I'm just going to take the tail off for a second. If we take the we can see in here, so again there's the board for our Kate robot. That's connected to our two DC motors, so we've got them right here hiding inside of the wing, and then we can see that these wings will then turn around. This one is a little bit fragile, so it doesn't always work, but I do have a video of it working on my YouTube channel if you're interested in checking it out. So again, starting to take something like the Kate, basic as a robot body, but if you take out the board, you can start to get a little bit creative with cardboard. And we know how students have a wonderful imagination with cardboard. And so these are exciting opportunities to explore with. So another robotic board that is out there is called the Gigglebot. And so this is made by Dexter's Industry. And we can see how it's got a nice little form factor, Lego compatible base, so you can go ahead and start building on top of that, which is really fun. It's also got some onboard LEDs as well, so you can see those starting to go ahead. And then you can also start to bring in some other technologies as well, like you can laser cut something and strap it on there. And so something like this you can use with your students to get creative and building with as well. So, and you can see here on the front, you can connect other alligator clips. And on the bottom here, we also have those light sensors to do some line following activities. So another fun extension for the microbit. The last extension that I wanted to talk about was the bit booster. So this bit booster here is just this red board, and really has some great opportunities for students and for young people and for old people to get creative. And so here's an example using my old Lego NXT Technic kits, and you can go ahead and create something like a robot. And this one is going to go ahead and probably fly off the table. So this one, if I press button A, it drives, button B, it stops. So again, we can see it's got some nice LEDs here, which we can use as sort of outputs based on things that the sensors pick up. We also have, as you can see, and you can probably tell, this is Lego compatible, so it builds nicely into the Lego Technic kits already. And then we can see how we can use this in various buildings. So students, we already know, are very curious and creative with Lego, and so we can just, give them a challenge or two, and we'll see where they go with that. And then the last little project that I wanted to show you is again using some Lego, but in this case it wasn't to make a robotic kit, it was to make a carnival game. And so a little bit of backstory on this particular project. My son and I, we were doing some exploring with the microbit and building. We wanted to go ahead and build a game of sorts. And so we had first thought of well, what if we had a sort of a table, and we were throwing things at it, and trying to get a cup in a hole type of thing. So that was fun. And then I thought, well, let's try to integrate a microbit into it and see how we can do that. And so again, well, we thought about, well, we can get these this sort of a round disc with these little cups on here, that would be able to maybe turn while we're trying to play this game. So if I go ahead, turn this on, you can see that it's sort of turning at different paces. So if I use button A, it goes at the faster pace, and then I have an external push button here that I can stop it, and then button B will go at a slower pace. And so this is more for the younger crowd. And then we got the button B again. So just to going through some of this, the build with this, with my son and I. So we first started off with the our disc and just the wheel here. And so I thought, and we sort of discussed, and maybe just the wheel by itself would be good enough. But at first, it was very wobbly, so it was very unstable for us to be able to use. And so our next thought was, well, what if we take and build a sort of balance of this flywheel over here? And so we went ahead and built this one flywheel. There's still a little bit of unstableness to it. So again, thinking about, well, how can we improve this? So again, thinking about that engineering design process, the design thinking process, how can we improve this? So we went ahead and added a second flywheel to it. And so the second flywheel, again, helped with that stability, but it didn't really help us as much as maybe having a third one. And so we started to talk about, like, what makes something stable and what have we learned. So in terms of, like, when you're younger and you've got two legs, you're not as stable as when you're older and you've got more comfortability with it. So you sort of stay on four legs because that's better. And then thinking about a tripod, having those 3 points of contact allows to have a very stable nature to it. And so again, thinking about that, we were able to sort of come up with our this is I would say our final design for this, but that might change if we want to continue adding to it. But there is our sort of our project. So I'm going to jump back over and share some more resources and more opportunities. But again, thanks very much for letting me show you some of my projects that I've had fun creating. All right, so now we're back over here, and I want to share a few opportunities that you might want to share with your students in thinking about bringing the microbit and making into the classroom. So the microbit website has got some great resources, and one of the challenges that actually just got launched at the beginning of October is called the Do Your Bit Challenge. So it's a microbit challenge that's linked to the global goals. And so those global goals that are the UN sustainability goals that we've pushed towards trying to get or solve by the year 2030. And so I would invite you to explore those global goals. And this year's goal challenges is goal number 3, so health and wellness, and then goal number 13, climate change. And so those opportunities are really exciting to be able to bring into your classroom with those. I also wanted to share some resources with you, and this slide deck is going to be available for you to go through. But again, thinking about some of the getting started, there's some great projects on the microbit website, some great lessons to be able to use. If you're interested in purchasing some, they also have the reseller available on the website. And then I've also started a Wakelet collection for you to think about getting started and some of those other resources available. Again, I wanted to thank you for attending this session. And if you're interested in any workshops and any types of technology, we'd be happy to come into your classroom to support your students. and also to support your teachers with teacher workshops. And please feel free to reach out and share anything with me. Thanks again, and have a great summit. Bye.